Thanks to Brilliant for supporting this episode of SciShow. Go to brilliant.org/scishow to learn more. In 2019, Google researchers announced that they had achieved quantum supremacy. That does not mean that they're ushering in a new sci-fi future, as far as we know. It sounds very grandiose. Instead, it describes what might be the first useful quantum computer, an entirely new way of performing calculations that's better than anything we've got right now. But not everyone thinks that Google actually got there, or that quantum supremacy is even a thing worth worrying about. To understand what this means, we've got to go way back to the basics of how computers work. If you've been told one thing about a computer, it's that deep down, everything is just ones and zeros. And amazingly, this very simple fact is more or less true. The principle behind your everyday modern computer dates back to a landmark paper published by British computer scientist Alan Turing in 1936. He described a theoretical device we now call the Turing machine, capable of solving any problem with just 3 simple actions. The machine could read a 0 or 1 from a bit of memory, like a strip of paper. It could also write a 0 or 1 to that bit of memory, or it could move to an adjacent bit. Mathematicians have proven that by combining those 3 actions with a set of rules about when to use each one, the Turing machine is capable of solving any mathematical problem. It was theoretical at the time, but now every modern computer is basically just an extremely complicated, very small, really wonderful Turing machine. These devices now are starting to be called classical computers. Quantum computers, on the other hand, wait for this, have bits called qubits that can represent a 0, a 1, or any combination of the 2. To understand what that means, we gotta use quantum physics' most famous or infamous problem. Yes, the cat one. This thought experiment, first proposed by Austrian physicist Erwin Schrödinger, imagined a cat locked in a box with a poison device. At a random time, that device would activate and kill the cat. Until you open the box, you can't know whether the dirty deed has actually happened, so in a sense, the cat is both alive and dead while hidden from view. We've simplified this. Now, Schrödinger's whole point with this is that the world we're familiar with, the classical world, doesn't work like this. But the quantum world does. The cat is both alive and dead, but only with quantum particles. Now let's get back to qubits. When you read the value of a qubit, you only ever get a 0 or a 1, just like the cat can only be alive or dead in the end. But which you get is all up to chance. Every qubit has a probability of being a 0 and a probability of being a 1, a combination called a superposition. But what the chances of each are is based on how the qubit is set up. What's more, the values of different qubits can be linked together in a process called quantum entanglement. That means that if you measure the state of one entangled qubit, you also get information about its buddies. This adds up to, well, math. By entangling qubits in certain combinations, engineers can solve some of the same kinds of problems that they can with classical computers. It's the combination of superposition and entanglement that gives quantum computers their theoretical power. Basically, they should be able to do the same things, but way faster. In principle, a quantum computer can perform a calculation very quickly by representing all possible outcomes at once, and then finding the correct one. Which brings us back to quantum supremacy. It's the idea that this approach can solve some kinds of problems that classical computers can't, in a practical amount of time, that is. But unlike the physics that actually makes quantum computers work, the idea of supremacy, of being better than classical computers, is pretty imprecise. Like, what counts as an impractical amount of time? Also, quantum computers might be better only for certain specific kinds of problems. So does that matter? Google's announcement that they had achieved quantum supremacy has put these questions front and center. They constructed a device consisting of 54 qubits made of tiny loops of superconducting wire and capable of representing around 10 quadrillion states. With it, they created a quantum random number generator and generated 1 million numbers in just 200 seconds. And after running some tests on the world's most powerful supercomputer, they concluded that the machine would take about 10,000 years to do the same thing. But it didn't take long for a research group at IBM to respond, claiming they could program the same supercomputer to do the simulation in 2.5 days, while also providing extra accuracy. This is why it would be nice to have a more solid definition of quantum supremacy. 2.5 days is not 10,000 years, but it's still about 1,000 times slower than 200 seconds. But we don't necessarily need a quantum random number generator. Classical ones work fine. So even if this is quantum supremacy, does that matter? We at SciShow are not qualified to say, but what's clear is that quantum computers are getting better, and that has profound implications for the world we live in. Take, for instance, cryptography. Every time you log into your computer or check your email, your data is protected by encryption. That encryption only works because classical computers can't efficiently solve certain kinds of math problems. The code protecting your bank account, for instance, isn't unbreakable. It would just take so long that the bad guys don't bother. But what if something that today takes 10,000 years suddenly takes 200 seconds? That's the kind of change quantum computing represents. In a way, you can think of these machines totally like classical computers in the 1950s. They fill rooms, require tons of power, and are only useful for certain kinds of problems. But year by year, they're getting smaller and more powerful. We can debate how much progress has been made, but progress is being made. If human history is any indication, we will get there sooner or later. Whenever quantum computers do become a thing, they're gonna need quantum computer programmers, and you can learn computer science yourself with the courses on Brilliant.org. Like the in-depth course on data structures, which is all about the fundamental ways computers store and manipulate data. By the end of the course, you'll know exactly how computers store data easily and access it quickly. Brilliant has dozens of courses like this one. In addition to computer science, they cover science, engineering, and math. Each one is designed to be hands-on and to keep you engaged the whole way through. Courses are even available offline via their Android and iOS apps, so you can keep learning on the go. The first 200 people to sign up at Brilliant.org/SciShow will save 20% on an annual premium subscription. So if you've been telling yourself you want to learn to code, here's your chance. And by checking them out, you're helping support SciShow. So thanks.